Okay, let's solve this. Consider this system where k is a positive constant. There exists a value of k, a plus b root c, where a, b, c are positive integers, c has no perfect square factors greater than 1, where the system only has one solution. Find a plus b plus c. Okay. So we somehow have to figure out where this is only one solution. So I'm trying to look if there's any patterns here. Does this fit into anything here? I don't think so. Um, okay, well I can multiply both sides by x plus 2y and this, and then maybe I can get something. Uh, would that help me? And then maybe I could square both sides here and then get something I could substitute. So let's try. So 6 times 1 plus y is equal to x times x plus 2y. Um, so then expanding this, 6 plus 6y is equal to x squared plus 2xy. Ooh, if I square this on both sides, we get x squared plus 2xy squared, or plus y squared is equal to ky. So we could recognize here that this is this. So this is just ky minus y squared. 6 plus 6y is equal to ky minus y squared. Um, then can we just solve for y? So y squared is plus 6 minus k. Oh, this isn't b. That's really annoying. Y plus 6 is equal to 0. So something to note here is that this is in b, and b is used a lot in the quadratic formula, so it's going to be very annoying to use. So I mean, I could use that, but also, if this only has one solution, then there should only be one value of y, unless the other one isn't valid for some reason, but we're just not going to worry about that for now. That means that this should be able to be turned into something y minus something, or plus or minus something squared. So that means that if we have it that way, it needs to be, what is it? This is one half of this. This is one half of this squared. So c is equal to b over 2 squared. So reversing that, root c is equal to 2 root c is equal to b. So 2 root 6 is equal to this. So 6 minus k is equal to 2 root 6. So k is equal to 6 minus 2 root 6. I mean, no, this does not work. Because it needs to be positive constant. Yeah. So for some reason this is wrong. I don't know why, but it's wrong. This is positive. This will be positive 2. I mean, technically this could be negative and that wouldn't change anything. Why don't I try that? So it's just going to be equal to negative this. Wait, what? this middle thing, we're going to swap these two around. K minus 6. K minus 6. So this, 6 plus 2 root 6, I think this should work. Because then, okay, let's say it's that. Then y squared plus 2 root 6 plus 6. Then we factor it y minus root 6 to root 6y squared is equal to 0. Y is equal to root 6. Does that invalidate anything here? X plus y is equal. Oh my god, why is this square root in a square root? Oh no, but it cancels out because. No, it doesn't. I don't know. X is equal to root ky minus y. If x is equal to square root of 6 minus 2 root 6 times root 6 minus root 6, then we get is equal to square root of 6 root 6 minus 2 root 6 is going to be minus 12 minus root 6. Man. But our constraint is that x plus 2y cannot equal 0, and that seems to be true. 1 plus y can't equal 0, that seems to be true. I think this is right, so that means that a plus b plus c is equal to 14. My only concern is that there seems to be two correct answers, or two answers that could be correct. I don't see why the negative one can't be correct, other than this can't be negative, but it doesn't say, like, there should only be one correct answer that I should be able to eliminate without knowing this. But I guess, let's see, I'll check. So I feel a little silly. It's totally correct. And we are told all numbers in the answer are positive, so we can just use that. That's what it literally said in the solution. So I feel like it was a bit crazy to get it right. I was not expecting to get that right, not super expecting it. But I don't know. It's cool. I guess I'll see you guys tomorrow. Goodbye.